Welcome to the lecture on getting system design. In this lecture, we will go on solving certain problems based on getting system design. Let us start with the first question, that is, a down sprue of 180 mm length has a diameter of 20 mm at its top end. The liquid metal in pouring cup is maintained up to 60 mm height. What should be the diameter of the down sprue at its lower end to avoid aspiration? So, in this question you have been given a pouring cup and a down sprue. So, then the down sprue length is 180 mm. So, this length is 180 mm. which is normally we take as H2. Then diameter of 20 mm at its top end. So, this point is 0.2. So, here the diameter D2. So, at this point you have D2. So, H2 is given as 180 mm and D2 is given as a diameter of 20 mm. The liquid metal in the pouring cup is maintained up to 60 mm height. So, the liquid metal is maintained up to this height and this height is given as 60 mm, and we by convention we write as height of the pouring cup. So, height of the pouring cup is given as 60 mm. So, basically we write HT, that is total height, and total height becomes HC plus H2, and that becomes HT equal to 240 mm. Now, what they want is at this point, so this is the point 3 and here the diameter is D3. So, what should be the diameter of the down sprue at its lower end? Here you need to find D3 so that there is no aspiration. So, the condition to avoid aspiration is it has already been derived in the previous lecture. The condition to avoid aspiration is if this is A3 and if this is A2. So, A3 upon A2 is nothing but under root HC upon HT. So, this is the condition of avoiding aspiration. So, A3 will be pi by 4 and D3 square divided by pi by 4 D2 square. This will be under root HC. So, SC is given as 60 divided by HT is given as 240. So, we have to calculate HT is given as 240 mm. So, it will be 240 and this comes out to be 1 by 2. So, what we from here we get D3 upon D2 equal to 1 by root 2, and from there we have to find D3. So, D3 will be D2 upon root 2, and it is nothing but root 2 times d2 upon 2, and d2 is given as 20. So, root 2 into 20 upon 2, 1.414 into 20 upon 2 . So, this is nothing but 14.14. So, this is the diameter at the bottom end of the sprue, which will avoid the aspiration in this problem, and that is why 14.14 mm is the answer. Now, we will deal with the next question. The next question is given as like this: a mold of dimension 60 centimeter by 30 centimeter by 14 centimeter is to be filled by liquid metal using top pouring method. So, we have been given a mold whose dimension is given, 14 centimeter is the height of the mold. The liquid metal height above the top surface of the mold is 14 centimeter. So, height of the metal head, since we are doing the top pouring, so the height of the metal head over the top surface is given as 14 centimeter, and the area of the gate is 6 centimeter. The point from where the metal enters into the casting cavity, that cross sectional area is 6 centimeter square. Find the time taken to fill the mold. So, we have to find the pouring time when we do the top pouring of the casting. Also, find the time taken when the mold is filled using bottom pouring, the height of liquid metal in the vertical column being the same. So, it seems the height of the liquid column was earlier 14 centimeter, and also the height of the cavity is or mold is 14 centimeter. So, in the second case, when we do the bottom pouring, the top portion of the liquid metal in the vertical column or in the pouring cup will be same as the top surface of the casting cavity. So, what will be the time taken to fill the liquid metal? Now, in this case, let us see, we have a cavity, so this height is 14 centimeter, width is 30 centimeter, and length is 60 centimeter, and we are basically pouring from here, and this is the pouring cup, and this height also is given as 14 centimeter. So, this is the case of top pouring, and in that case the area of the gate AG, this area is AG, and AG is given as 6 centimeter square. So, for top pouring, we have to find the time taken. So, time taken will be volume upon volumetric flow rate. Volumetric flow rate will be area of the gate multiplied by velocity of the fluid at the gate. So, volumetric flow rate, this is the flow rate of the metal which is entering into the cavity. So, it will be area of gate multiplied by velocity of metal at the gate. So, now velocity of the metal, so this is nothing but Ag, and velocity of metal at the gate, since being the top pouring in this case, your velocity will be under root 2 g h. So, it will be under root 2 g into h, 14 centimeter. So, Ag is given as 6. So, 6 times under root 2 into 981 into 14. Volume is, so time will be volume is 60 by 30 by 14. We have taken G as 981 gram per centimeter square. So, it is in that case 981 centimeter per second square, sorry. So, that is the value of G in that unit. So, it will be divided by this volumetric flow rate 6 into under root 2 into 981 into 14. So, we have to find it. So, it will be 981 multiplied by 14 multiplied by 2 under root is 165.73 into 6. So, it is 994.4. So, 25200 upon 994.41, and so it will be 25.34 seconds. So, this is the time taken to fill the cavity when the cavity is being poured using the top gating or using top pouring. Now, let us see how much time it will be taking when we are going to do it using bottom pouring. So, in the case of bottom pouring, what will happen? You have the cavity so, in this case your pouring cup will be here and it will be entering at this point. So, this is your 14 centimeter and you have the dimensions like the earlier one 60 centimeter, 30 centimeter and 14 centimeter. So, in this case this is your pouring cup and this height is same. Now, if you go for bottom pouring, so up to this stage we have done it for top pouring. Now, we will calculate for bottom pouring when the liquid metal is supplied at this point. Now, for the bottom pouring, as we see, in this case the total height is 14 centimeter and height of the mold is 14 centimeter. So, using the bottom pouring, we know that for bottom pouring time taken is AM upon AG under root 2 upon G under root HT minus under root HT minus HM. So, this is the formula which we had derived for finding the pouring time for bottom pouring. Now, in this case we will have all these values. AM is nothing but the cross sectional area of this mold. So, AB is given as 60 multiplied by 30. So, 60 multiplied by 30, you have AM as 60 multiplied by 30, that is 1800 centimeter square. Then AG is given as 6, then under root 2 upon under root 981, that is under root 2 by G, then root HT, so root 14 minus root ST minus HM. So, ST and HM are same, so it will be 0. So, you have to calculate these values. So, if you calculate the values, it will be (300) into 1.414, that is 4242, or we can do under root 28 so we can have 300 under root 28 upon 981. So, that will be 0.1689. So, it into 300. So, it is 50.68. Now, this is the time taken to fill the mold using this bottom gating. When we do with top gating, the time taken is 25.34 second, whereas when we do the bottom gating, the liquid metal head is the same. In that case, the time taken is 50.68. What we see incidentally is that the time taken is basically 2 times this. So, we have also earlier seen that in those cases when we replace this height with this, then this time using the bottom pouring is 2 times the time taken by the top pouring, and that is why we have got this time. The next question what we are going to solve is based on this figure. In the figure shows a mold along with riser for casting a plate 20 centimeter by 20 centimeter by 5 centimeter. So, there is a plate of dimension 20 centimeter by 20 centimeter by 5 centimeter, 5 centimeter is the height. So, this is a rectangular type of cross section plate with 5 centimeter of height. Find the area AG such that the mold and the riser can be filled within 10 seconds after the down sprue has been filled. So, this is a problem which tells that there has to be 2 types of filling. One is the filling of this plate which is will be done using the top pouring for this, using this height of the liquid metal, and with the similar height of liquid metal you have to fill this height of the riser which is cylindrical in shape, the diameter is 15 centimeter and the height is 18 centimeter. So, the 2 portions are to be filled up, one by top pouring method, another by bottom pouring method, and the condition is given that this should be done within 10 seconds of the time. So, let us see what will be the time taken? So, in this case what is given, let us first write. For the mold, when we take about the plate, for plate, if we get the time taken, since it is a case of top pouring, so time taken will be volume of the plate divided by the volumetric flow rate of the plate, that is area of the plate into so this is the area of the gate into velocity at gate. So, this is the basically time taken when we take the time taken for the plate portion. So, the volume is 20 by 20 by 5. So, it is 2000. Then area of the gate which is to be found multiplied by under root 2gh. So, since it is a case of top pouring, so for this you have the case of top pouring. So, under root 2gh, and h is in this case is 18 centimeter, g is 981 centimeter per second square. So, if we find this value, it will be so 2000 divided by Ag into 174.52, that is 11.46 upon Ag. Sorry, there was a mistake here. This value will be 187.92. So, this value will be 2000 upon 187.92, that is 10.64 upon Ag. So, this is the time taken to fill the plate portion. Now, time taken to fill the riser. So, in this case you have bottom pouring. Because the riser is at a level above than this level of the gate. So, this is a case of bottom pouring. In this case you have Am as pi by 4. This is a cylindrical casting, cylindrical riser. So, pi by 4 into 15 square. Ag has been given already, area of the gate is given. So, Ag is to be found out, and we need Ht. So, Ht is given as 18 centimeter, that is height, and Hm, that is height of the mold, that is also 18 centimeter. So, if we take the bottom pouring, the time taken, so time taken will be Am upon Ag under root 2 by G under root Ht minus under root Ht minus Hm. So, since Ht and Hm are same, so this term will vanish to 0. So, we are left with this term. This will be equal to Am is pi by 4 into 15 square upon Ag, that is we have to calculate into root 2 upon root 981 multiplied by under root h t. So, that h t is given as 18. So, it will be under root 18. So, what we have to do is you have to have pi into 225 into under root 2 under root 18. So, basically that will be 6 divided by a g into under root 981, and there will be 4 here. So, let us have its value. It will be 225 into 3.14 into 6. So, that is 4239 upon 981 under root. So, it will be 31.32 into 4 Ag. So, it will be 4239 divided by 125.28. So, it is 33.84 upon Ag. So, what we see is in one case we are getting 10.64 upon Ag using the top pouring, and when we go for bottom pouring we are getting the value 33.84 upon Ag. Now, these two timings together they should not exceed 10 of seconds. So, if we take the limiting time, we need to have total time, you can take the limiting case as 10 seconds. So, this is your T1 and this is your T2. So, that is T1 plus T2 you have to equate as 10. So, you can have it like this 10.64 upon Ag plus 33.84 upon Ag will be 10. So, it will be 44.48 upon Ag will be 10, or Ag will be 4.448 or 4.45 seconds. So, this is a time which will be required. So, this is the total time. So, that shows that, so this is 4.4 not seconds, it is the centimeter square. 4.45 centimeter square is the area of the gate which will be able to complete the filling of this cavity in 10 seconds. So, this is all about the solving of such problems. Whenever we encounter such problems, we can see that you have a case of something like a parting line type of gate where you have something poured at the down level and something poured at the top level. So, you have to find the time taken for both the parts and then you have to add them and the conditions are met. So, you are getting some value. So, this is how you can solve the problems. Thank you.